Hi Josh, today I will be presenting my presentation about the annual high temperature effects on frequency and intensity of the St. Lawrence River flooding in Montreal. Here is my outline, which contains 5 parts: background information, study area, methods that I use or introduce, the result of my study, and conclusions. Every year, new record-breaking floods affect residents along the St. Lawrence River. Especially huge flood events happened in the year 2017 and 2018, fueling the argument between natural climate variability and climate change. This project aims to analyze whether global warming is leading the flooding events more intense and serious within the year 2000 and 2019. Discuss the trends between global temperature anomaly and river discharge records from chosen hydro station since the year 2000. Use satellite images from different years to compare the changes after flooding events. The study area is the hydro station located in the southeast corner of downtown Montreal. There are 2 methods I use for this project. Method 1, the Clausius-Clapeyron equation. Based on Dr. Alfieri's theory, the Clausius-Clapeyron equation is modified for liquid-vapor phases by assuming that the vapor is an ideal gas and that the volume of the liquid phase is negligible in comparison with the volume of the vapor. The relationship between the temperature of liquid and its vapor pressure is not a straight line. The vapor pressure of water, for example, increases significantly more rapidly than the temperature of the systems. This indicates that warmer air temperature is linked to increasing atmospheric water vapor content, which in turn determines the total perceptible water. I download the atmospheric temperature anomaly data from NASA official webpage and the data from hydro station. Then I put them into Excel in order to make a line graph to see the changes over the years. The mean water level line graph indicates an upward trend that the St. Lawrence River Montreal section has risen from 21.09 meters in year 2000 to 21.86 meters in year 2019, which is following the same increasing trend as the atmospheric temperature anomaly graph. Methods 2. I use ArcMap to calculate NDWI of 2 maps of year 2007 and year 2019. As the NDWI maps showing on the right side, values of water bodies are larger than 0.5. Vegetation has much smaller values, which results in distinguishing vegetation from water body easier. Build-up features have positive values between 0 and 0.2. The far right side map with purple color shows the differences between 2 NDWI images. The blue parts are the areas that have been flooded over 12 years. Here is the data of spring flooding in Canada. We can see that there are 383 square kilometers areas were flooded of the year 2019. And here it comes to the results part. On one hand, the timing and severity of ice jamming is intimately linked to the nature of the preceding ice season. It has been shortened by approximately 3 weeks between 19th and 20th century, based on Professor Terry's report. Also for the past 10 years, rates of speed of ice jam formation and melting was accelerating, which would cause the water level to soar in a short time. As a result of global warming, the sea level is predicted to rise by as much as 40 to 110 cm over the next century. Because the water surface river slope is typically very small near river mouths, the river-sea interaction region will shift many kilometers inland. This could produce a great variety of physical, chemical, and ecological changes, particularly for the near-shore marine and estuarine systems. From the ice jam perspective, it would most likely create new problems by moving the sites where there is an abrupt change in slope. A known ice jam instigator, the flatter the river access slope and the higher the water level rise. The further upstream are such effects likely to migrate. Riverside communities and nearby infrastructure such as bridges, roads, or railway lines may be particularly vulnerable. On the other hand, based on the prediction by using general circulation models, the amounts of winter and spring precipitation across Canada, especially in the more northern latitudes, would increase 10 to 20% than previous decades. No need to mention that the St. Lawrence River also has to regulate the large volumes of water from the Great Lakes region, which will definitely increase the probability of flooding events of St. Lawrence River. Finally, the conclusion part. St. Lawrence River water level has increased by 0.7 meters within 20 years. It has an ignorable connection with the rising temperature caused by global warming, especially on two aspects that mentioned previously: acceleration rates of the formation and melting on ice jam, and increasing frequency and amounts of precipitation. It is urgently for the Canadian government to improve flood warning systems and countermeasures to cope with irreversible global warming trends. Thank you.